module, you will learn about common forces in mechanics and friction. Common forces in mechanics are gravitational force, which is the weight of a body, contact forces between moving pairs of links in a machine, tension in cables, and tension or compression due to elongation or compression in springs. In this module, we will focus on contact forces. An example of a contact force is the force between a box and the table on which it is placed. The contact force between the box and the surface of the table can be resolved into two components. One along the normal to the surface in contact, and the other parallel to the surface. The component perpendicular to the surface is called normal reaction, and the force parallel to the surface is called friction. Let us conduct a simple experiment to formulate an empirical relationship between normal reaction and frictional force. Place a cuboidal-shaped wooden block weighing 100 Newton on the wooden table top. The weight of the block will be acting vertically downward and will press the tabletop down. The tabletop will press the block up with a force equal to the weight of the block. The upward force of the tabletop on the wooden block is known as normal reaction. Let us now try to slide the wooden block by pulling the spring balance attached to the block. As we slowly pull harder on the spring balance, the friction force automatically increases and becomes equal to the applied pulling force. This automatic increase of the frictional force takes place up to a limit only. The frictional force at this point is known as limiting frictional force. At this point, the applied pulling force is equal to the limiting static frictional force. The block is at the point of impending motion. That is, the block is on the verge of moving but is not actually moving. We can repeat the experiment by placing the wooden block in different positions, such that different surfaces are in contact with the tabletop. We will find that the limiting frictional force is same in all cases. If we repeat the experiment by using a stone and an iron block in place of a wooden block, we will find that the limiting frictional force is different in all cases. Limiting friction increases as the mass of the block increases. We find that the limiting frictional force is independent of the contact area between the two surfaces. When the block actually starts moving, the frictional force experienced by the block is known as the kinetic friction force. The kinetic frictional force is always slightly less than the static limiting frictional force. From the results of this experiment, we can arrive at an empirical relationship between normal reaction and limiting frictional force. These empirical relationships are also known as the laws of friction. They are: static limiting friction is independent of area of contact. Static friction is proportional to normal reaction. It is equal to the product of mu s and n, where mu s is the coefficient of static friction. Kinetic friction is proportional to normal reaction. It is equal to the product of mu k and n, where mu k is the coefficient of kinetic friction. If the force F applied on the block is greater than the friction Fk. Then the net force on the block is F minus Fk. And the acceleration A of the block is the ratio of the net force on the block to its mass. If F is equal to Fk, then the net force is 0, and hence the block moves with uniform velocity. If F is less than Fk, then the net force is negative, and it leads to retardation of the block. If we slowly increase the inclination of the surface on which the block is placed, there comes a point where the block starts sliding. At this point, the weight of the block, which is equal to mg, acts vertically downwards. If theta is the inclination of the surface with the horizontal, then mg sin theta acts down the plane and the static friction acts up the plane as shown. Thus, mg sin theta is equal to Fs. The normal reaction on the block acts perpendicular to the surface as shown, and it is equal to mg cos theta. As per the laws of friction, if μs is the coefficient of static friction, then Fs is the product of μs and n, which is equal to μs mg cos theta. As the value of theta increases from minimum, the value of mg sin theta and as well as the value of Fs2 increases till the value of theta is equal to a maximum theta max. At this maximum value of theta, the block tends to move down the plane and experiences impending motion. Then the friction is limiting friction. In this case, mg sin theta max is equal to Fs max, implies mg sin theta max is equal to μs mg cos theta max, which gives tan theta max equal to μs on simplification. Now let us look at a rolling friction. When cylindrical or spherical shaped bodies roll without slipping on a cylindrical or flat surface, the frictional force is minimal. A ball or roller bearing fall in this category. To reduce the friction further, grease or lubricating oil is introduced between the surfaces. Air is used as a lubricant in high precision and high-speed equipment. Friction is desirable or undesirable depending on the situation in which it occurs. Friction between the moving parts of a machine is undesirable. We try to reduce friction by using lubrication. Friction is desirable when it occurs between the tires and the road's surface. Because of this friction, the automobile is able to move forward or stop when brakes are applied. We are able to walk only because of the friction between our feet and the ground. We would fall if we try to walk on a slippery surface. You have now reached the end of this module on friction. In this module, you learned that common forces in mechanics are gravitational force, contact forces, tension in cables, and tension or compression in springs. The component of a force perpendicular to the contact surfaces of two bodies is called normal reaction. The component of force parallel to the contact surfaces of two bodies is called friction. The frictional force at the point of impending relative motion is called limiting static frictional force. The laws of friction are: static limiting friction is independent of area of contact. Static friction is proportional to normal reaction. It is equal to the product of mu s and n, where mu s is the coefficient of static friction. Kinetic friction is proportional to normal reaction. It is equal to the product of mu k and n, where mu k is the coefficient of kinetic friction. Lubrication is used to reduce friction between the surfaces.